The output frequency is proportional to the voltage at terminal T61. The circuit we experimented with is a VCO. This circuit, as its acronyms indicate, is a voltage-controlled oscillator, that is, the frequency of the output signal depends on a voltage that will be applied at a point in the circuit, in this case at the input. Operation. The assembly bases its operation on the generation of a triangular wave at port U1A. This triangular wave is achieved by circulating a constant current through a Traves-Due capacitor C1. With the potentiometer you can control this current in such a way that you control the time it takes for the triangular signal to be generated and therefore the frequency of the output signal. The output signal would be useless if there were no circuit that caused instability and converted it into an oscillator itself. This is achieved by introducing two gates that cause a delay and generate oscillation. The resulting signal is amplified using a transistor before reaching the output speaker. Therefore, in the speaker we will obtain a variety of frequencies that can be the basis for experimenting with electronic music, which is one of the possible applications of this type of circuits. The circuit. The circuit has three stages, each of which has some clearly defined functions. The first part is formed by the pot potentiometer, R1, C1 and U1A. This part is responsible for generating a triangular signal by charging the capacitor at constant current through pot and R1. The next stage is formed by ports U1B, U1C and resistors R2, R3 and R4. This step is what produces the circuit oscillation taking advantage of the delay produced in gates U1B and U1C. Resistor R4 is what transmits the oscillation towards the U1A port, allowing the capacitor to discharge and therefore the generation of the triangular wave, the basis of the circuit. So that the output signal does not change, an intermediate port is placed, U1D, which is used to deliver signal to the output stage formed by transistor Q1 that reaches directly to the speaker, which is connected to the collector circuit. Putting it into operation. The circuit should work when the power is turned on. The failure to do so may be caused by an incorrect connection of one of the components, so we will carefully review the assembly, starting with the integrated circuit power supply and the Q1 transistor terminals. Experiment 1. The circuit has a considerable variety of frequencies, which are obtained by acting on the pot potentiometer slider. The values of these frequencies are due to the value of the pot, R1 and C1 components, so that by changing any of them a different range of frequencies can be obtained, which can be seen in the variation of the speaker tone. Experiment 2. We can vary the polarization of transistor Q1 to vary its polarization. In this way, if we increase R5 and/or R6 well, we obtain a lower power output. On the contrary, if we reduce these values, we will obtain greater power. This last operation can end up being a bit risky if we are not careful so as not to destroy the transistor. To avoid this, we will decrease the base resistor, trying not to go below 2K2.